code to be fully supported across all browsers, and build a worm that is kind of site or floor independent. I mean, you've seen the Stalk Daily code there, and if anyone's seen Sammy's code, you'll know that they were written very specifically for a specific floor and a specific site. If you could find a way of writing a kind of a universal or generic cross-site scripting worm, then you could have whatever you want to call it, an intelligent hybrid super worm. Now, PDP and Billy Hoffman have done some great research on this. I'd recommend, if you want to learn more about this specific issue, take a look at it. But really what they're proposing is if you can build this kind of generic worm code that can go to sites like xss.com, and I think there's an area on RSnake's forum as well that talks about new cross-site scripting attacks, but mainly xss.com. If you go there, it not only tells you the site that was exploited, but I think you know exactly where the floor is and so on. If you could go to that site, pick the top 50 off and go and automatically exploit all of those with a worm similar to Sammy or Stalk Daily, then you could be talking at millions of people infected, depending on who you're exploiting. And then lastly, one of the things that I don't think we've seen on a wide scale yet is using cross-site scripting worm infections for distributed denial of service attacks. If you think Sammy essentially had 1 million plus browsers under his control at one point or another. Now what if he would have used every one of those to make 100 or 1,000 requests to your website? You're talking the kind of traffic that not many websites would be able to handle, you know, hundreds of millions of requests. So we've not really seen that yet, but it's something that is possible. If you've got a big enough amount of people infected, then people might use it in the same way as they would use a traditional kind of botnet. So the next thing I want to quickly look at is feed injection. So like I said at the start, with Web 2.0, we don't want people to have to come back to our site every half an hour to see if we've made an update to our blog. We want them to be able to pull that down automatically with things like RSS and Atom and using readers to pull that down. Now the problem is, again, kind of like with any other of these problems, if you pull that data down and use it without validating it, then you open yourself up to attack. So we kind of have two kind of main differences between readers. Ones that are either web browser-based or web-based, or ones that are on the desktop. And there are kind of clear differences between the security issues between the two of them. Well, when you're in the browser, you're a little bit limited to the kind of damage you can do to the user. You know, things like cross-site scripting, cross-site request forgery, you know, they're possible through remote zone risks, as I call them. So the remote zone readers, whilst you're in the web browser, you can, you know, cross-site script the user and so on here. But you're kind of limited to that context, and we'll look at a local zone reader in a second of a real-world vulnerability there. But in the remote zone, if you just pulled in this RSS story and put it into the reader without doing any validation, then that code could execute. And in this example here, it's just stealing their cookie and sending it to my cookiemonster.cgi. Again, it just comes back to input validation, essentially. Validate that before you use it. And that's one of the things we'll look at later on is fixing security vulnerabilities doesn't have to be particularly complex, in my opinion. And we'll look at what I mean on that a little bit later on. So the local zone risks, this is where we have kind of a reader installed on the desktop. And what that can give an attacker is access to read and write content from the file system. You'll be able to use things like ActiveX components to do a lot of different interesting things. And we'll again see a vulnerability in a second where someone was able to execute any Perl code he wanted on your computer just through injecting a malicious feed. Basically, with these local zone readers, what a lot of them do is they pull down the feed, write it to a HTML file locally, and when you want to view that feed, you click on it, it takes it out, puts it in the browser, away you go. And when you're using those readers, you're in the local context, so if a vulnerability exists there, then you can read and potentially write from the file system. So an example here is if I injected that into a feed and you came along in your local reader and tried to view it, then what it's essentially doing is it's grabbing a file called secrets.txt, using one of those ActiveX components to allow me to take that data out to my filemonster.cgi. Now obviously when a user clicks on this, you'll get an ActiveX pop-up saying, do you want to allow this? 9 times out of 10, the user just thinks it's asking, do you want me to go to that website for you to get your news? They'll click yes, and you can steal secrets.txt. So a real-world vulnerability here in a local zone reader called YASA. Basically, part of this application was a thing called GUI.pm. Now, when this presentation goes up online, I've got all the code for GUI.pm in the notes if you want to step through it and see the vulnerability for yourselves. But basically what that did was it took in the URL, and when you wanted to view it, it put it into an exec statement and launched the browser without doing any validation on the URL. So what the researcher figured out was that, fine, well, I'll exploit that then. So he was passing in the link, putting his semicolon at the end, and doing a Perl -e and, well, whatever he wanted at the end there, really. So again, there's nothing really complicated about that attack. But again, it just shows, lack of validation, for example, allows him to do essentially whatever he wanted to with that Perl on the system. So how can these attacks get worse? Well, I think if you could find a vulnerability in a widely used site and a widely used reader, so I know something like the BBC news site and a popular reader, I'm not really up on what's popular in RSS readers, but Google Reader, for example. If you could find an exploit in both of those, so you could inject malicious code into the BBC site, which then exploits the flaw in all the Google Reader users, then obviously you could have wide-scale exploitation of users. And whilst you're down on the client side in particular, you can do a lot of things like data theft, port scanning, and so on. If you can find the vulnerability, as you saw with the YASA vulnerability there, you're only, in that case, limited by your Perl skills, really. So mashup and widgets, and kind of where I say widgets here, that means anything that could be regarded as a widget, Facebook applications, things you put on NetVibe sites, page flakes, all of those types of things. I couldn't find a common term for it, so I just called it a widget for now. So really kind of mashup sites and widget sites, I guess, are kind of a good example of Web 2.0 sites. So a mashup site will pull in data from different sources to give you one single output, and a widget site is essentially a blank canvas site for a user. They can come along, use something like iGoogle, and build the web page that they want to see first thing every morning. So we'll look at two examples in a second, but I found this site for a mashup that I thought was actually quite interesting. What this site does is it takes in news feeds, I don't know where they get them from, but Reuters in this case, and it's looking there and it's saying that story has come from London, so I'll take you to London on Google Maps. Simple example, but we see a lot of similar types of sites to that out there where they take something and show it you on a Google map. The problem is, and like I said, Douglas Crockford said that a mashup is essentially a self-inflicted cross-site scripting attack, but we're pulling multiple inputs and giving it to you in one output as a user. Now, we're pulling that data from multiple sources, and again, if you don't validate that and just push it straight out there into one place for the user, then you can exploit the user. If you think of maybe a similar example to the one we just looked at, maybe a photo website where you take your photos and you put a location tag in there saying where you took the picture. Now, if someone comes along and he wants to map your photos to Google Maps, then you might have to provide your photo site logon details to him. Now, normally if you go to your photo site, it's probably SSL'd and so on, and you're comfortable with the fact that your credentials are probably protected in transit. But how do you know that the mashup site, that essentially that man in the middle, how is he handling that data for you? Is he taking a copy of it from himself? Is he just sending over HTTP instead of SSL? And I guess whilst I'm speaking at DEFCON, probably everyone's thinking, well, SSL is not that great either. But the point is, if he's not protecting it in transit, then you can lose that data. And mashups, they by default, by their design, they have to have that cross-domain access. So again, if we were still relying on same origin policy, it's kind of goodbye to those types of protections anyway now. And then ultimately the mashup site is the middleman, and you have to decide, do you trust the mashup site itself? On the example before, I'd probably trust Reuters, I'd probably trust Google Maps, but the output I'm getting is strictly speaking not from